This video discusses the various solving methods available in RISKOptimizer. If you haven't already done so, you should view the RISKOptimizer introduction video in this guided tour series first. The example it illustrates uses the common solving method, the recipe method. The recipe solving method treats each variable as an ingredient in a recipe, and it tries to find the best mix by changing each variable's value independently. However, there are several other solving methods, each designed for a particular type of optimization model, and examples of them, drawn from the at-risk example files, are illustrated here. This video won't actually show the optimization and final results. Its only purpose is to illustrate the types of solving methods available and how to set them up. You can perform the actual optimization in the RISKOptimizer example files. The order method. The order method is probably the second most popular solving method, behind the recipe method. It is used in models where the goal is to find the best permutation, or ordering, of a set of tasks. An example is shown here, where the goal is to find the best ordering of jobs with given due dates to minimize some aspect of lateness. To specify the model definition, you select the job indexes in row 11 as the adjustable cells, you click the Group button, you select Edit, and you specify Order as the solving method. There are the choices. That's all. And it looks like this, the order solving method for these indexes. Then it will find the best ordering, the best permutation of the numbers 1 through 10 to minimize some aspect of lateness. A RISKOptimizer model can actually have several groups of adjustable cells, each with its own solving method, but all of the examples illustrated in this video have a single group. Once you have a set of adjustable cells and you want to change its solving method, you select Edit from the Group command. If you want to identify a new set of adjustable cells with a different solving method, you would select New from the Group command. The project method. The project solving method is very similar to the order solving method, except that certain items or tasks must precede others. The project solving method can be used in project management to rearrange the order in which tasks are carried out, ensuring that the order will always meet the precedence constraints. It can also be used in other contexts, such as the example shown here. This model is a variation of the classical traveling salesperson model, where a salesperson must start in one town, end in another town, and visit each town exactly once. There are precedence constraints on the route, right here. For example, towns 23 and 7 must be visited before town 3. The objective is to minimize the mean total hours traveled. Uncertainty is introduced by letting the speed on any leg of the trip be normally distributed with mean 55 miles per hour and standard deviation 5 miles per hour. As in the order solving method, the goal is to find a permutation of the town IDs, those in column G. However, only permutations that satisfy the precedence constraints are allowed. For example, in the solution shown, town 35 is visited first, town 29 is visited second, and so on. So, because of the precedence constraints, town 3 must be further down the list than either town 23 or 7. This is exactly what the project solving method ensures. You can see that this solution isn't allowed because, for example, town 7 is visited before town 13. And the precedence says it should be the other way around. You choose the adjustable cells and solving method exactly as in the previous order example, but now you must indicate the preceding tasks range when you specify the adjustable cell settings. So it's using the project solving method, but the tasks range is columns I to K, right here, the precedence constraints. And again, RISKOptimizer will find a permutation of these indexes that satisfy the precedence relationships and minimizes mean total hours traveled. The budget solving method. The budget solving method is useful when the adjustable cells, or some subset of them, must sum to a fixed number, such as 100%. In such cases, the recipe solving method could be used with a constraint on the sum, but the budget method eliminates the need for this constraint. It finds first the sum for the original values of the adjustable cells, and it maintains this sum throughout the optimization. The model shown here is a financial retirement planning model. The details can be found in the Planning for Retirement example file, but the important aspect for now is that the adjustable cells, the weights for the person's portfolio in row 8, must sum to 100%, as they do in this initial solution. Therefore, these adjustable cells are specified to be between 0 and 1, and the budget solving method ensures that they will always sum to 1, that is 100%. The grouping method. The grouping method is a specialized solving method for cases where you want to find an optimal grouping of items. In the model shown here, the goal is to assign each of 80 securities to one of 5 groups so that the groups are as even as possible. Specifically, the total future value of each group is calculated in column J, and the objective is to minimize the standard deviation of these totals. This is a perfect candidate for the grouping solving method. The model definition is shown here. Each adjustable cell in column G indicates which group the security has been assigned to. The grouping method is used. Note that RISKOptimizer determines the possible groups, in this case 1 to 5, from the distinct values in the adjustable cell range. Alternatively, you can specify the range of group IDs as shown here. The schedule method. The schedule method is another very specialized but also very powerful solving method. It can be used to find the optimal scheduling of events when there are constraints on which events must occur with other events, that is at the same time, before other events, and so on. The model shown here is an example, and you can learn more about it in the Scheduling Classes with Uncertainty example file. Each adjustable cell in column F indicates which time slot to assign to each class, and the objective is to minimize a penalty function, a combination of the number of excess classes that can't fit in available rooms and excess students that can't be accommodated in the classrooms. The constraints are spelled out in the constraint table. The 3 chemistry classes must be scheduled at time slot 1. The 3 biology classes cannot be at the same time slots as the 3 corresponding chemistry classes, and the 3 history classes must be at the same time slots as the corresponding sociology classes. The model definition is shown here. The time slots in column F are the adjustable cells. The scheduling method is used. There are 6 time blocks allowed, and the constraint cells come from the constraint table. So again, this method is very specialized, but for models like this one, it can be very useful. Again, you will probably use the default recipe solving method for the majority of your RISKOptimizer models. But the solving methods discussed here provide a tremendous amount of flexibility on the types of models you can optimize. This video briefly discusses the optimization settings that you can choose for your RISKOptimizer models. If you haven't already done so, you should view the RISKOptimizer introduction video in this guided tour series first. You can view or change settings from the RISKOptimizer dropdown. This opens a dialog box with 3 tabs. The Runtime tab provides settings on when to stop the search for the optimal solution. In general, it is difficult to know how long to run a RISKOptimizer optimization. It often finds a very good solution fairly quickly and then spends a lot of time trying to find slightly better solutions. You can experiment with the runtime options, but the one shown here, the default of running 1,000 trials and then stopping, often works fine. Of course, if you notice from the progress window that the objective is still improving as the optimization stops, you can increase the number of trials. The Engine tab, shown here, allows you to choose between 2 optimization algorithms, a genetic algorithm or the OptQuest algorithm. Here you see them. The OptQuest algorithm is new to At-Risk 6.0, and it is often superior to the genetic algorithm in terms of speed. If you select Automatic, the default option, RISKOptimizer will choose the algorithm that it thinks is best for your particular model. You can override this automatic choice, as shown, but you should understand the options well before doing so. You can read more about these algorithms in the At-Risk help files. Finally, the Macros tab allows you to run macros during the optimization process. However, you have to write the macros in Excel's VBA programming language, so this option is for advanced users. One final option you see in the RISKOptimizer dropdown is Constraint Solver. This is useful when the genetic algorithm is being used and there are constraints in the model. If the original solution is not valid, that is, the values in the adjustable cells do not satisfy the constraints, the algorithm might have to run many simulations just to find a valid solution. In this case, Constraint Solver can be run first. It runs an optimization in a special mode, where the goal is simply to find a valid solution, and it quits as soon as a valid solution is found. Then, starting from this valid solution, the regular RISKOptimizer algorithms can be used to find the best solution.